Hello everyone, in this video I'm going to talk about special trigonometric values or trig values. In particular, I'm going to talk about sine, cosine, tangent, cotangent, secant and cosecant theta values for these particular degrees. So 0 degrees, so your theta is could be 0 degrees, 30 degrees, 45 degrees, 60 degrees, and maybe 90 degrees. And from these values, you can go ahead and find the other values, other standard values. One thing to note here is that all these values are in the first quadrant. So if I were to draw a rectangular coordinate system, okay, that's my x and y. So all these angles are in the first quadrant, meaning that all the values are going to be positive. As you know, that the signs in the quadrants for trig functions goes as follows: all positive in the first quadrant, in the second quadrant sine and its reciprocal cosecant, and then in the third tangent and cotangent, and in the fourth secant and cosine. So now, having said that, let me go ahead and start with 0 degrees first. I am going to share with you my personal experience of learning these things. So let's say this is my triangle, okay? This is my triangle, and that's my theta. And that's going to be the opposite, right? This is the opposite, and this is the adjacent, and that's the hypotenuse. First value I try to remember is sine of 0 degrees. Sine of 0 degrees. What value is it going to be? As you know, sine of theta is what? Opposite over hypotenuse. So sine of theta is equal to opposite over hypotenuse. Now think of kind of rotating the hypotenuse kind of this way. So if it were to get here, then my opposite is gonna get smaller. If it were to get here, my opposite is gonna get even smaller, right? Then ultimately it'll get very, very close to the x-axis. Let's say this is my x-axis or horizontal value, right? So very, very close to the adjacent side. So that means this opposite is going to get very, very close to 0. So if this value gets very, very close to 0, or ultimately it gets to 0, then my sine is going to go to 0. So I remember sine of 0 is 0. So that's one thing you want to remember. Then the complement of 0 degree is 90 degree, okay? So it means that cosine of 90 degrees is gonna be 0. So complements of sine and cosine, they are the same, okay? So if you consider the complementary angle, now you probably know two angles are complementary if they add up to 90 degrees. Now, so I got sine 0 degree, which is 0. That means cosine of 90 degree is going to be 0. Then also, if I know sine 0, I can find cosine of 0. Remember this formula. That's going to help you all the time. Sine square of theta plus cosine square of theta is always going to be 1. In my case, it's sine of 0, right? Sine square of 0 degrees plus cosine square of 0 degrees is going to be 1. But my sine 0 is 0, right? So sine square 0 is going to be 0. So it's going to be 0 plus cosine square of 0 degrees is equal to 1, or cosine of 0 degree is going to be plus or minus 1 if I take the square root, of course, of both sides, right? However, remember, we are in the first quadrant, so we'll just stick to the positive value for now. So cosine of 0 degrees is 1. I have created a table here for you to kind of record all of these values. So far, what did we get? We got sine of 0 is equal to 0. So sine of 0 is equal to 0. And cosine of 90 is 0. So cosine of 90 is 0. Then I found cosine of 0 is equal to 1. Okay. Now using the same formula, sine square theta plus cosine square of theta, if cosine of 90 degrees is 0, then sine of 90 degrees is going to be 1, because this formula, sine square theta plus cosine square theta is equal to 1, can be used to find the other values. Okay. Now that we found 0 degrees and 90 degrees, let's jump into 30 degrees. So let's find sine of 30 degrees. So this one you kind of have to memorize. Sine 30 is equal to 1/2. Okay, so this is one of the values I want you to memorize along with the other values. So let me write down the values that you'll need to memorize. Okay, there are many ways people do it, but please use whatever suits you and whatever makes you feel comfortable, or follow along what I am doing. So now we found sine of 0 degree is equal to 0. If you know sine of 0, then you can find the cosine of 90 and cosine of 0 degree, and then sine of 90 degrees as well. So just remember this value. So now this is another value, sine 30 is equal to 1/2, that you will have to remember. So sine 30 is 1/2. So what is the complement of 30 degrees, which is 60 degrees, because 30 plus 60 is 90. So it must be the case cosine of 60 degrees is equal to 1/2. Okay, so this one you have to memorize. This one you have to memorize. Okay. So sine 30 is 1/2. So cosine 60 is going to be 1/2. Now, I know sine 30. What is my cosine 30 going to be? Again, I'm going to be using the formula sine square of theta plus cosine square of theta is equal to 1. And you can do the math. You will see it comes out to be square root of 3/2. Just for example, I will do 1. Okay. Sine square of theta is 1/2 whole square, right? Sine square of 30 degrees plus cosine square of 30 degrees is equal to 1, and cosine square of 30 degrees is equal to 1 minus, take this on the other side, 1/4, which is, by the way, gonna give you cosine square of theta is equal to 3/4, or cosine of theta is equal to plus or minus square root of 3/2. Now remember, this plus or minus kind of tells you which quadrant the theta falls in. But for simplicity, we are considering only the first quadrant. So what do I get here? So sine cosine 60, okay, so cosine 30 is going to be square root of 3/2. Now, what is the complement of 30 degrees? 60 degrees. So it must be the case sine 60 is square root of 3/2. And the last value you have to remember is sine 45 degrees, which is square root of 2/2. But if you are watching these videos from maybe some other parts of the world where they write this as 1 over square root of 2. Okay, it's the same thing, by the way. And because square root of 2, you could break it 2, you could break it down to square root of 2 times square root of 2, right? 2 square root of 2 times square root of 2. These cancel out. That gives you this. Now, we have sine 45 is equal to square root of 2/2. But what is the complement of 45 degrees? There is also 45 degrees. So cosine of 45 degrees is going to be square root of 2/2. So these are the three values that you need to remember. Once you remember that, you can find other values. Okay, so remember sine 0 degree is equal to 0, sine 30 degree is equal to 1/2, and sine 45 degrees is equal to square root of 2 over 2. Then you can find all the other values. Given that you remember this formula, sine square of theta plus cosine square of theta is equal to 1. Now that you know sine and cosine, you could find tangent by taking the ratio of sine over cosine, right? You could find the cotangent by taking the ratio of cosine over sine, right? And the secant 1 over cosine and cosecant 1 over sine. So if you find technically just sine theta value for anything, you can find the rest. Now that's for the first quadrant. However, how does it work for the second, third, or fourth quadrants? To find the values for the second, third, and fourth quadrants, I would remind you about the signs of trig functions depending on which quadrant does the angle land in. As you may remember, all students take calculus. So that means in the first quadrant, it's all positive. In the second quadrant, all students, as for student, that means sine and sine theta and cosecant theta, 1 over sine theta is going to be positive here. And then the third quadrant, tangent theta, all students take tangent theta, T for tangent, and cotangent theta are going to be positive. And in the last quadrant or the fourth quadrant is going to be all students take calculus, C for cosine. So cosine of theta and secant theta, reciprocal of it, is going to be there. I mean positive, and everything else is negative. So remember, in the first quadrant, all positive. In the second quadrant, sine and cosecant theta is positive. Everything else is negative. In the third quadrant, tangent theta and cotangent theta are positive, but everything else is negative. And in the fourth quadrant, it's going to be cosine theta and secant theta positive. Everything else is negative. So let's say I want you to find the value of sine of 135 degrees. All right. You could write it as sine of 180 degrees minus 45 degrees. Which, by the way, using the complementary rule, supplementary rule, you could write it as sine of 45 degrees. But you already know sine of 45 degrees, which is square root of 2 over 2 or 1 over square root of 2, whatever way you write it. Okay. What about if I want you to find, let's say, sine of, let's say, 180 plus 30, okay? So it's going to be 210 degrees. 210 degrees. Oh, by the way, I forgot to tell you something here, which is this falls in the second quadrant, right? So 135 degrees falls in the second quadrant, so sine is positive. And I forgot to mention about that, sorry. So we don't need to worry about the sine. However, this time we do. So sine of 210 degrees is going to be sine of 180 degrees plus 30 degrees, which falls in the third quadrant. But in the third quadrant, sine is going to be negative. So this is going to be equal to, so you can ignore the 180 degrees, okay? So just put the sine of 30 degrees. But in the third quadrant, sine is negative. So that's why you need to put a negative sign. And negative, then sine 30, you know from here, which is 1/2. So it's going to be negative 1/2. So sine 210 degrees is negative 1/2. What if I gave you sine 300? Sine 300 degrees. That you could write as sine 360 degrees minus 60 degrees is the same thing, sine 300, which, by the way, is going to land you in the fourth quadrant. Right here, 360 minus 60 is 300 degrees. That's going to put you there. Now, in the fourth quadrant, however, sine is negative, right? So it's going to be negative sine of 60 degrees. But you know sine of 60 degrees, which is square root of 3 over 2. So this is going to be negative square root of 3 over 2. So this is how you'll find the special values like 0, 30, 45, 60, and 90. However, sometimes these angles are not represented in degrees. Actually, it's represented in radians. Please remember that pi radians, we put C here for radian, pi radians equals to 180 degrees, okay? Or if you want to write it other way, pi rad is equal to 180 degrees. Some special values, so 30 degrees is gonna be pi over 6 radians. So instead of 30, you may end up saying pi over 6. Then 45 degrees is gonna be pi over 4 radians. And then 60 degrees is gonna be pi over 3 radians. So these are values you may see in terms of radians. So make sure that you are comfortable in converting this. And 90 degrees, by the way, is going to be pi over 2. And 180 degrees, of course, is pi radians. So this is basically how you'll find the special values for trig functions, sine, cosine, tangent, cotangent, secant, and cosecant, all of this. And when you have larger angle or bigger angle that does not fall in the first quadrant, make sure that you are clear on which quadrant does it fall in, which quadrant does the angle land in. And based on the landing position, it could be on second, third, or fourth quadrant. Based on where it lands, you determine what the sign of the trig function is going to be in that particular quadrant, and then you adjust it accordingly. But in the first quadrant, everything is positive. I hope that this discussion was helpful. Thank you very much.